Most organizations treat ESG reporting like a narrative. Auditors treat it like evidence. And evidence has rules: origin, integrity, repeatability, and access control. If your number exists because someone edited a spreadsheet, your stack isn't a stack, it's a story. In this episode, this is what gets built: a minimal, auditable OESG architecture on Microsoft Cloud that you can replicate: identity, immutability, governed calculations, lineage, and a reporting layer that doesn't rewrite history. And there's one reason dashboards are the fastest path to audit failure. Coming up, the foundational misunderstanding. ESG isn't a report, it's a system of record. The core misconception is comforting. ESG is a document, a disclosure, a set of charts, a few paragraphs that say we're improving. That framing works right up until someone asks for proof. In architectural terms, ESG is not a report, it is a system of record. That distinction matters because a report is an output artifact. It can be produced by almost any workflow, including workflows that should never survive contact with assurance. A system of record is different. It is a controlled environment where inputs, transformations, and outputs are all tracked, replayable, and attributable. And OESG, operational ESG, is simply the adult version of ESG: measurable, decision-ready, and auditable. If ESG is going to be used in corporate disclosures, regulatory submissions, or investor communications, the underlying system has to behave like financial reporting systems, not in theme, in mechanics. So the anatomy starts with a control system model: inputs, transformations, outputs, and attestations. Inputs are the operational facts: energy consumption, fuel use, travel, procurement line items, workforce counts, water usage. Transformations are the governed processes that normalize units, map to organizational structure, apply emission factors, and compute KPIs. Outputs are the period-specific KPI tables and disclosures. Attestations are the approvals, sign-offs, and audit artifacts that prove the outputs were produced under control. Most organizations skip straight to outputs. They build dashboards, they produce slides, they call it reporting, but they never build the chain of custody. Chain of custody is the real product, not the pretty chart, because assurance doesn't audit your chart. It audits whether the number behind the chart is defensible, where it came from, who touched it, how it changed, which logic produced it, and whether anyone could have quietly altered it after close. This is where deterministic versus probabilistic ESG shows up. Deterministic ESG is boring, and boring is good. Given the same raw inputs, the same factor versions, and the same calculation logic, the system produces the same outputs every time. Rerun last year in 2 years and you get the same result. That's what auditors expect, even if they don't say the word deterministic. Probabilistic ESG is what you get when human edits are allowed to masquerade as process. Numbers drift because someone fixed a file, optimized a model, or updated a mapping. The system still produces an output, but it can't reproduce its own past. It can't explain itself. It can't prove integrity. And once you can't reproduce, you can't assure. Here's the thing most people miss. Auditors don't need perfection. They need controllability. They need you to show that changes are visible, bounded, approved, and attributable. When you can't do that, every number becomes a debate. And debates are expensive. So let's talk about the audit questions that break weak stacks. Not because auditors are evil, because this is their job. Who changed it? When did they change it? Why did they change it? What approval existed? What version of the factors did you use? What version of the calculation logic did you use? What inputs were in scope for the period close? Who had access to alter raw data, curated data, and reported outputs? Can you show lineage from the KPI back to the source record without reconstructing a PowerPoint? If your answer to any of these is we think, you don't have OESG. You have a narrative. Now here's where it gets uncomfortable. Most ESG programs treat the sustainability team like the owner of truth, but systems don't care about job titles. Systems care about permissions and pathways. If a single person can both submit data and adjust the calculation and publish the dashboard, you don't have governance. You have conditional chaos. And it accumulates. Every exception becomes an entropy generator. One more undocumented pathway for numbers to change without leaving a clean trail. This clicked for a lot of teams when assurance started asking for evidence packs, not just the final KPI, but the supporting documents, the factor library provenance, the ingestion logs, the validation results, and the approvals. Suddenly, the ESG report wasn't the deliverable. The deliverable was the ability to prove the report. So the architecture has a simple objective: enforce chain of custody at scale. That means every ESG number has to be traceable through 4 properties. Origin: the system can identify the source record and the source system. Transformation: the system can show which pipeline and which logic produced the derived record. Integrity: the system can show the data wasn't overwritten post-close, and changes are recorded as new versions or adjustments, not silent edits. Access: the system can show who could touch what and when. Once you accept ESG as a system of record, everything else becomes obvious. Dashboards become presentation, not computation. Spreadsheets become controlled submissions, not a source of truth. One-off fixes become formal adjustments with approvals, and every component you choose in Microsoft Cloud starts mapping to a property the auditor will eventually demand. Now, before we go further, you need a working definition of auditable in system terms, because it's not a checkbox and it's definitely not a screenshot. That comes next. The audit-grade requirements: immutability, reproducibility, lineage, separation of duties. So what does auditable mean when it stops being a vibe and starts being a system property? It collapses into 4 requirements, not because Microsoft says so, because auditors behave predictably and systems either withstand that pressure or they don't. Immutability, reproducibility, lineage, and separation of duties. First, immutability. Immutability is not, we promise we won't change it. Immutability is, the platform will not let you change it. That's the entire point. On Microsoft Cloud, that shows up as write once, read many behavior on Azure Blob Storage or ADLS Gen 2 through immutable storage policies. After period close, your raw evidence and your period outputs have to stop being mutable objects and become records. That distinction matters because most ESG programs close a period socially, not technically. People agree it's closed, but the storage layer still allows overwrites. So someone fixes a typo, reruns a pipeline, uploads a corrected file, and now the evidence for the closed period silently changes. Your process still feels controlled, but the system behavior is not. Auditors don't audit feelings, they audit whether changes were possible. Time-based retention is the operational version of immutability. You lock data for a defined interval, so it can't be modified or deleted. Legal hold is the litigation version. It stays locked until someone with authority clears it. The consequence is the same either way. Overwrites become illegal, which means your pipeline design has to evolve from replace to publish a new version. Second, reproducibility. Reproducibility is the ability to rerun FY1 in FY+2 and get the same result. Not similar, not close, the same. That means 3 things must be frozen per period: inputs, factors, and logic. Most people only freeze inputs, and even that is usually wishful thinking. The system needs to freeze the factor library versions used for that period and freeze the calculation artifacts that reference them. If you rerun with latest factors or latest code, you're not reproducing history, you're rewriting it. Reproducibility is why dashboard math is an audit trap. You can't prove what logic produced last year's number if the logic lives in a constantly edited semantic model. Even if the code is technically visible, it's not governed like a calculation engine. There's no concept of a period-bound release, an approved version, and a locked output. Auditors don't need your DAX to be clever. They need it to stop moving. Third, lineage. Lineage is the answer to a single question that destroys weak stacks. Where did this number come from? Not philosophically, mechanically. Lineage is origin to transformation to consumption, source system record to ingested file or table, through transformations, into curated models, into reported outputs, into the dataset that Power BI reads. If you can't trace it quickly, you will trace it slowly. And slowly means meetings, screenshots, and spreadsheet archaeology. That is not assurance, that is theater. Microsoft Purview exists because human memory does not scale. It's the metadata system that turns "we think this is how it flows" into "here is the graph." It also becomes your change management weapon. Before you change a pipeline or a calculation, you can see downstream impact. Without Lineage, every change is a blind deployment into your own reporting boundary. And yes, product capabilities evolve. That's normal. Your requirement does not evolve. The requirement is explainability under pressure. Fourth, separation of duties. This one is where most ESG programs quietly fail because it's inconvenient. But the logic is simple. The person who submits data cannot be the person who approves it, and the person who changes logic cannot be the person who publishes the reported outputs. You need role separation across data entry, validation, calculation, approval, and reporting. In Microsoft terms, Entra ID is not a diagram. It is the enforcement mechanism. Group membership, role assignments, access reviews, audit logs, these are evidence. And you don't get evidence by saying only the sustainability team has access. You get evidence by proving which identities had which permissions during the period and showing that privileged access was bounded and reviewable. Most organizations end up with a hero admin because it's faster. It is not governance. It is a single point of audit failure. So those 4 properties define your architecture. Immutability prevents silent edits. Reproducibility prevents drift. Lineage prevents archaeology. Separation of duties prevents conflict of interest and invisible power. And here's the payoff. Once these exist, your ESG stack stops being a collection of tools and becomes a control plane. Now the uncomfortable part. These requirements map directly to specific Microsoft services. Some are non-negotiable. The rest are optional until scale and regulation make them mandatory. Microsoft Stack Map, non-negotiable versus optional. Now we map those 4 audit-grade requirements to Microsoft services, not as a shopping list, as a chain of enforcement. Because the system doesn't become auditable when you buy tools. It becomes auditable when every requirement has an implementation that removes human discretion. Start with the non-negotiables. These are the components auditors implicitly expect, even if they never say Microsoft out loud. First, identity and access. Microsoft Entra ID Entra is not single sign-on. Architecturally, it's the distributed decision engine that decides who can submit, who can transform, who can approve, and who can publish. And it produces logs. Logs are evidence. If role separation is one of your requirements, Entra is where it either happens or it doesn't. Second, storage with immutability. Azure Data Lake Storage Gen 2 with immutable storage policies for the zones that become evidence, raw and period closed reported outputs, plus any evidence vault you keep for supporting documents. This is the part everyone tries to negotiate away because it forces pipeline discipline. But Worm isn't a feature, it's a behavior change. Once you enable immutability, overrides are no longer a quick fix. They are an audit event you can't perform. That constraint is the entire point. Third, a governed calculation zone, Fabric Lakehouse or Azure Synapse Analytics. Pick one and treat it like an accounting engine. Versioned artifacts, controlled deployments, and period-bound releases. Your calculations need to live where they can be tested, reviewed, and rerun against frozen inputs and frozen factors. If your KPI logic lives in Power BI measures, you didn't build a calculation zone. You built a dashboard that quietly rewrites history. Fourth, governance and lineage. Microsoft Purview. Purview is the difference between "we can probably explain this" and "here is the lineage graph, here are the owners, here are the transformations." Under assurance pressure, that difference becomes the whole game. Purview is also how you scale governance beyond tribal knowledge. People leave, your metadata can't. Fifth, reporting as a thin layer. Power BI. Power BI is allowed. Power BI is useful. Power BI is also where most teams destroy auditability by turning the semantic model into the calculation engine. So the rule is brutal. Power BI consumes reported period closed tables. Measures are presentation and aggregation, not emissions accounting. You want auditors to argue about your visuals, not your logics. So that's the non-negotiable baseline. Entra, ADLS Gen 2 with immutability, Fabric or Synapse for calculations, Purview for lineage, and Power BI as the last-mile presentation layer. Now the optional components. Optional does not mean irrelevant. It means not required until scale, regulation, and complexity corner you. Microsoft Sustainability Manager sits in that category. It's optional when you already have mature emissions logic, a controlled factor library, and the willpower to build transparent pipelines and models yourself. It becomes valuable when you need faster onboarding to frameworks, faster Scope 3 workflows, or you simply don't have internal emissions domain depth. The platform has audit trail capabilities and data trail reporting features, but it doesn't absolve you from architecture. If you treat it as a black box that spits out numbers, you're just outsourcing your audit risk to a product configuration. Azure Data Factory is also optional, but only if your ingestion needs stay simple. If Fabric native ingestion covers your source systems, fine. But when you have real ERP integration, IoT telemetry coordination, multi-step API dependencies, and cross-system timing constraints, Data Factory becomes the orchestration layer that keeps ingestion deterministic. Just remember the immutability constraint. Data Factory pipelines that overwrite files collide with worm policies and fail. That failure isn't a bug. It's your architecture revealing itself. Azure Machine Learning is optional in the purest sense. Use it for forecasting, anomaly detection, and scenario modeling, never for baseline numbers. Model outputs are estimates, and estimates need labeling, provenance, and governance like any other input. Otherwise, your AI insights become untraceable logic changes with a brand name. Here's the short warning. Every optional tool becomes mandatory the moment you use it to create or modify numbers inside your reporting boundary. The system doesn't care that it was a pilot. If it touched the number, it's part of the evidence chain. So you now have the map. Non-negotiables enforce the 4 requirements. Optional tools add capability, but also add pathways for entropy. Next, you start at the edge, because the first place truth gets corrupted is always the first place data enters your system. Operational data sources, where OESG actually comes from. OESG doesn't come from your sustainability team. That team usually collects it, begs for it, cleans it up, and tries to defend it. But the data originates somewhere else. Operational systems that were never designed to be audited for carbon math. That's the first architectural truth. If you don't treat the source systems as part of the reporting boundary, you'll spend your life explaining downstream numbers while upstream inputs keep changing. So let's name the real sources and the real damage they can do. Start with ERP, SAP, Dynamics, whatever you've standardized on. ERP is where activity data becomes audit-friendly because it already has controls, transactions, approvals, posting periods, master data, organizational structure. But the trap is that teams try to use the ERP outputs as already reported sustainability data. They shouldn't. You want the activity data: fuel purchases, freight costs, inventory movement, utility invoices, travel expenses, procurement line items. The thing most people miss is that ERP is better as an evidence source than as a calculation engine. It's good at capturing business events with identity and timestamps. It is not good at emissions factors, allocation logic, or multi-scope reconciliation unless you deliberately build it that way. So ERP is a source of facts, not a source of finished ESG truth. Next, energy meters and IoT telemetry. This is where teams get excited about granularity and then quietly drown. Telemetry is high volume, high frequency, and low forgiveness. You can collect 1 million readings and still fail assurance because you can't explain context. Which facility, which meter, what unit, which time zone, what calibration assumptions, what mapping from meter to asset to business unit. Telemetry without context is not data, it's noise with audit liability. And because IoT pipelines often involve gateways, edge buffering, retrees, and late arriving events, you need to design for time. Event time versus ingestion time, and what happens when the real reading shows up after period close. If you don't decide that early, your close process becomes a permanent argument with your own sensors. Now, HR systems. Workforce metrics sound simple until you try to define them consistently. Headcount, turnover, diversity, health and safety incidents, training hours, these are all HR managed and they are sensitive. That creates two constraints: access control and aggregation. You don't want raw employee records wandering into analytics workspaces because someone wanted a dashboard. For OESG, HR systems should feed controlled aggregates with documented definitions and a stable organizational hierarchy mapping. Otherwise, you get denominator drift. The metric stays the same name, but the population changes silently. Auditors don't need to see personal data. They need to see that the metric definition didn't mutate. Then procurement and suppliers, which is where scope 3 stops being theory and becomes operational humiliation. Supplier data comes through surveys, portals, partner feeds, invoices, and sometimes email attachments that should never be admitted into an evidence chain. The variability is the point. Suppliers don't share the same systems, the same data quality, or the same incentives. So you need to capture two things from day one: coverage and confidence. What percentage of spend or categories have supplier-provided data, and what percentage is estimated? Those flags aren't nice to have. They're the only honest way to survive questions about completeness. And if you don't store supplier submissions as evidence artifacts with identity, timestamps, and versioning, you will not be able to prove what was known at the time of reporting. Now, the radioactive source, spreadsheets and CSV files, they're allowed. They're also the birthplace of Final V7 CSV, which is the universal symbol of uncontrolled modification. Spreadsheets are not evil, they're just not control systems. They don't preserve chain of custody by default, and they make it trivial to change history without leaving a durable trail. So, in an audit-grade stack, spreadsheets are treated as controlled submissions. Metadata captured, schema validated, approvals recorded, and then the content gets ingested into the raw zone as append-only evidence. The spreadsheet itself becomes supporting documentation in the evidence vault, not the system of record. Here's the checkpoint. Every source system has its own native controls, gaps, and failure modes. ERP brings structure but tempts reported outputs. IoT brings volume but lacks business context. HR brings sensitivity and definition drift. Suppliers bring variability and partial coverage. Spreadsheets bring speed and entropy. Once you accept that, the next step becomes obvious. Ingestion is where truth gets corrupted because ingestion is where humans still believe overwriting is a feature. Ingestion patterns, controlled pipelines versus human-driven upload rituals. Ingestion is where OESG dies in real life because ingestion is where teams still confuse getting data in with getting evidence in. Those are not the same. The design rule is simple. Ingestion must be append first. Overwrites are audit poison. The moment your process allows replace the file, you've created an invisible edit pathway inside your reporting boundary. And auditors don't need to prove you used it. They only need to prove you could. Append first means every load becomes a new object or a new version with a load identifier that never repeats. If you want to correct something, you don't edit history. You publish an adjustment with rationale and approval, and you keep the original as evidence. Now here's where most people mess up. They treat ingestion as a user interface problem. They build an upload folder. They write drop files here instructions. They call it a pipeline. Then the first late file arrives and someone overwrites the last one because the business wanted the dashboard to be right. That's not ingestion. That's ritual. A controlled ingestion pattern has 3 non-negotiable behaviors: orchestrated movement, validation gates, and telemetry that can be handed to an auditor without translation. Let's talk tooling because Microsoft gives you multiple ways to ingest and none of them magically make you auditable. Fabric native ingestion is convenient when your sources are straightforward. Files, tables, common connectors, predictable schedules, and you can keep the orchestration simple. The benefit is proximity. You're already in the lakehouse world, and you can land data close to where it will be processed. The failure mode is also proximity. Teams let convenience become a substitute for control, and they stop capturing the metadata that proves what happened. Azure Data Factory exists for the unglamorous reality: complex ERP integration, IoT coordination, multi-step API pulls, dependencies, retrees, and sequencing that can't be trusted to just run. It also has the operational surface area for governance: parameterized pipelines, run history, integration runtime behavior, and consistent patterns across many sources. But the constraint is brutal. Immutability will punish sloppy ADF designs. When ADF tries to overwrite a file in an immutable container, it fails. That's not Microsoft being difficult. That's your system proving that it was designed to rewrite evidence. So the pattern becomes: write to a mutable staging area, validate, then publish into the immutable raw archive. Mutable staging, immutable archive. 2 zones, 2 behaviors. Now, validation gates. This is the part that separates ingestion from data dumping. Every load needs to be validated before it becomes evidence inside your system of record. And validation isn't just, did the pipeline run? It's, did the data meet minimum standards to be considered in scope? The practical gates are boring and therefore effective. Schema checks, column names, types, required fields, and allowed null behavior. Unit normalization, kWh versus MWH, liters versus cubic meters, distance units, currency, time zones. Required dimensions: site, region, period, scope category, source system identifier. And the system must record the outcome: pass, fail, quarantined, or accepted with exceptions. This is where you stop pretending spreadsheets are harmless. A controlled CSV submission is allowed only if it passes the same validation gates as an API feed. Otherwise, you've created a privileged path for human-supplied nonsense to enter the raw zone. Now, log everything, not for observability dashboards, for chain of custody. Every load should produce a durable record that includes a load ID, source system, extract window, ingestion timestamp, submitter identity where applicable, file name or object path, validation results, and the pipeline version that performed the load. This is where Entra shows up again. Submitter identity is not a name in an email. It's an authenticated identity tied to the submission event. If you can't attribute a submission to a real identity, you can't prove separation of duties. And if you can't prove separation of duties, you will eventually be asked why you believe your own data. There's also a subtle requirement most teams miss. Ingestion needs to be replayable. If someone asks, what did we know on March 31st, you can't respond with the current state of the lake. You need to be able to point to the exact load artifacts that were in scope at close. So ingestion isn't a pipe, it's a ledger. And once you build it that way, the downstream system gets easier. Curated models get cleaner inputs, calculations become stable, and period close becomes an actual event, not a calendar reminder. Next, the data has to be stored like it will be subpoenaed, because it can be. Storage anatomy: raw, curated, reported, plus an evidence vault. Storage is where good intentions go to die, because most teams store ESG data the same way they store project files. Whatever folder exists, whatever naming convention someone remembers, and whatever overrides still work. That's not storage architecture, that's entropy management without the management. An auditable ESG stack needs storage anatomy. Distinct layers with distinct rules, because different data states have different liabilities. You're not organizing data for convenience. You're organizing it so the system can prove what happened. So the baseline pattern is 3 zones: raw, curated, and reported. And then a 4th thing most stacks forget: an evidence vault. Raw is the closest to source landing zone. Append only, minimal transformation. The goal is not usability. The goal is preservation. Raw data answers one question: what did we receive from where and when? And that means raw objects need stable identifiers and immutable behavior after close. If you normalize units in raw, you've already destroyed provenance unless you also store the original. So raw keeps the original representation: the meter reading payload, the invoice extract, the supplier submission file, the export from ERP. You can add metadata alongside it. You do not fix it in place. Curated is where the data becomes usable. This is where you standardize, conform, and model. Curated data answers a different question. What does this mean in our organization? This is where you map source-specific fields into a common schema, standardize units, apply reference data like organizational hierarchies, and attach quality flags. The curated zone is where you deal with the reality that one system calls it plant, another calls it site, and a third calls it location, and none of them agree on identifiers. You resolve that here explicitly in versioned transformations you can explain. Curated is also where you keep truth with scars. You don't hide data quality issues, you mark them. Late arriving data, missing dimensions, suspect values, all of that becomes flags and exceptions, because clean data with no record of cleaning is just manipulated data. Reported is the period closed output zone. This is where KPIs become records. Reported answers the only question assurance really cares about: What did you report for this period, under which logic, using which inputs and factors? Reported data must be stable. Once the period closes, reported outputs do not change. If something needs correction, you don't overwrite reported tables. You publish an adjustment entry with references, what changed, why, and which approval allowed it. That's how financial systems work, and ESG doesn't get a special exemption just because it feels newer. Now, here's the thing most people miss. These three zones are not only about data shape, they're about access boundaries. Raw is restricted because it contains direct extracts and sometimes sensitive fields. Curated is restricted differently because it represents standardized enterprise data that can be widely misused. Reported is restricted because it's the official record. Different audiences, different permissions, same enforcement model, and then there's the evidence vault. The evidence vault is not a folder called supporting docs. It's a controlled repository for everything that proves the numbers. Supplier submissions, invoices, meter calibration records, calculation approvals, factor library provenance, mapping decisions, and period close attestations. This vault matters because ESG is not purely quantitative. Even when the KPI is a number, the justification often involves documents. The vault is where you store those artifacts with the same chain of custody expectations as raw data: who submitted it, when, which KPI or period it supports, and whether it was locked after close. If the supporting evidence lives in Teams chats in someone's mailbox, it doesn't exist in audit terms. It exists as a future argument. Now, naming and versioning, because mystery tables are an architectural failure, not a documentation failure. Every object needs a predictable name that encodes domain, source, period, and version. Not because auditors love naming conventions, but because humans do. You want an engineer to look at a path and understand whether it's raw or reported, whether it's preliminary or closed, and which period it belongs to. Versioning needs to be explicit. Latest is not a version. Final is not a version. Final 2 is a confession. So the storage anatomy creates a set of invariants. Raw preserves, curated standardizes, reported freezes, and the evidence vault proves. Once you have that, immutability stops being a storage checkbox and becomes a design constraint that your pipelines can actually survive. That's next. Immutability, worm. How to lock evidence without breaking your pipelines. Immutability is where good architectures stop being aspirational and start being inconvenient, which is why it works. In Azure terms, this is write once, read many, immutable storage policies on blob storage or ADLS Gen 2 that prevent modification or deletion for a defined period. Time-based retention locks data for a set interval. Legal hold locks it until someone explicitly clears it. Different intent, same effect. You can create and read, but you can't rewrite the past. That's the point. The mistake teams make is treating immutability as a storage toggle you enable later. But immutability isn't a feature you add. It's a constraint that changes pipeline behavior, deployment patterns, and how humans negotiate fixes. So let's be explicit about what changes operationally the moment you lock a container. Overwrites become illegal. Rerun the job becomes publish a new version. Fix the file becomes post an adjustment. And any pipeline that assumes it can land to the same path twice will fail loudly. Azure Storage will enforce the policy, and your orchestration will surface it as an error. In Data Factory, you'll see failures like path immutable due to policy when a copy activity attempts to overwrite or modify a protected path. That error is not a platform defect. It is the system preventing evidence tampering, accidental or otherwise. And this is the foundational misunderstanding. People think immutability is about security. It's not. It's about time. It's about making period close real in the storage layer, not just in a calendar invite. Now, there are two workable patterns that don't destroy your operations. The first pattern is immutable by design. Every ingestion writes to a unique, never reused object name, and you never need to overwrite anything. That means a path that includes a load identifier, plus a deterministic partitioning scheme, source, system, date, and maybe hour if you're dealing with telemetry. Each run produces a new object set. If the data arrives late, it lands as a new object set with a later load ID. You can still compute the same reported outputs because your close process selects which load IDs are in scope. The second pattern is the one most organizations actually need: mutable staging, validated publish, immutable archive. Here's how it works. You ingest into a staging area that is intentionally mutable. You can rerun pipelines there, fix mapping bugs, and iterate without fighting worm. Then you run validation gates. And only after validation succeeds do you publish to the raw evidence zone, which is immutable. Publish is not copy and delete. Publish is a one-way promotion. New immutable objects written with a stable naming convention, plus a metadata record that binds them to a load ID, pipeline version, submitter identity, and validation results. If you're using Azure Data Factory, this pattern becomes mandatory in some transformation scenarios because certain activities rely on temporary files during processing. Immutable policies prevent those temporary writes and cleanup operations. So you write to non-immutable storage first, then use a copy activity to move the finalized outputs into the immutable container. Again, inconvenient, predictable, correct. Now the subtle part. Immutability doesn't just apply to raw, it applies to anything you will later claim as evidence. That includes factor libraries for a closed period, the period closed reported KPI outputs, and the evidence vault documents that support disclosures. If those objects remain mutable, you can't prove historical integrity. You can only promise it. Auditors don't accept promises as controls. So you need a close process that includes a storage lock step. At period close, you freeze the selection of inputs, which load IDs are included. You freeze factor versions. You freeze the calculation logic reference. Then you publish the reported outputs and apply immutability to the reported zone for that period. You're not locking the entire lake forever. You're locking the slices that represent what we knew and reported. That distinction matters because you still need to operate next month. One more uncomfortable truth: immutability forces you to design for corrections. Corrections can't be overwrites, so they become adjustment entries, additive records that reference the original, carry a rationale, and require approval. If you do this well, you end up with something auditors understand immediately. The original evidence remains intact and the adjustment trail is visible and attributable. If you do this poorly, people will attempt to bypass the system. They'll hunt for a mutable folder. They'll ask for exceptions. They'll demand admin rights. That's not a people problem. That's you failing to design the only thing that survives entropy, an architecture that makes the right behavior easier than the wrong one. Next up is the hard part: calculations that don't drift, even when everyone keeps improving the logic. The governed calculation zone, Fabric Lakehouse or Synapse, not dashboard math. This is where most ESG stacks quietly rot, the calculation layer. Not because people can't do math, because they put math in places that can't be governed like an accounting system. Power BI is a presentation tool. It is not an audit-grade calculation engine. The moment your emissions logic lives primarily in DAX measures, you've made your numbers dependent on a file that changes whenever someone wants a new visual. That's not control, that's drift with a user interface. So the rule is blunt. Calculations live in a governed zone. Fabric Lakehouse or Azure Synapse Analytics. Pick one. Then treat it like a finance system. Versioned logic, controlled releases, testability, and reproducibility per period. Why this matters shows up the first time a stakeholder asks, why did last year's number change? And you discover the answer is someone edited a measure. That answer will not survive assurance. In a governed calculation zone, the primary artifacts are explicit and inspectable. SQL views, stored procedures, notebooks, and tables that represent outputs. You choose the artifact type based on what you can govern consistently, not on what your favorite engineer likes this week. SQL views can be clean for transparency. The logic is readable, diffable, and can be reviewed. Stored procedures can enforce parameterization and encapsulate controlled transformations, but they can also become opaque if people start hiding business logic inside procedural code. Notebooks are powerful for complex transformations and factor application, but they demand discipline, source control, approved releases, and consistent execution environments. Choose one dominant pattern for KPI computation and enforce it, because mixed paradigms are how you lose reproducibility. And this is the checkpoint most people ignore: unit consistency and dimensionality. Emissions calculations are not just multiplication. They are multiplication under constraints: site, region, period, source system, scope category, activity type, unit, and factor version. If any of those dimensions are missing or ambiguous, you will produce numbers that look plausible and fail under interrogation. So the governed zone has a job beyond computing. It enforces dimensional completeness. Every record must be joinable to organizational structure. Every activity record must carry a unit that can be normalized. Every computed record must carry the factor version key used, not DEFRA, not EPA. A version key that binds the output to a specific factor library snapshot. Now here's where period close mechanics stop being a meeting and become an implementation. For a close to be auditable, three things must freeze together: inputs, factors, and logic reference. Freeze inputs means the system records which load IDs or partitions are in scope for the period. You don't just have March data, you have these ingestion runs, validated, approved, included. Late arrivals don't overwrite anything. They become late arrivals, explicitly excluded or treated as adjustments. Freeze factors means the factor library used for that period is published with a version key and then locked as evidence. If your calculation queries join to latest, you've already failed. You're not calculating a period. You're calculating today's opinion of the past. Freeze logic reference means the exact calculation artifacts used are versioned and identifiable: a git commit, a release notebook package, a view definition version, something durable. The current notebook is not a version, it's a moving target. Once those three are frozen, the reported outputs can be generated deterministically and published into the reported zone. And Power BI consumes those outputs. That's the boundary. Power BI doesn't get to help by recomputing core emissions logic. Now, a common objection is, but we need flexibility. No, you need controlled change. You can change the model, you can improve mapping, you can add new factors, you can refine scope 3 categories. But every change becomes a new version with a new effective date and a clear statement of what periods it impacts. That's not bureaucracy. That's how you stop rewriting history by accident. If you remember nothing else, the governed calculation zone is where ESG becomes deterministic. Dashboards are where ESG becomes arguable. And once you enforce deterministic computation, the next dependency becomes obvious. Emissions logic lives and dies on factor management. Emission factors, versioning or your rewriting history. Emission factors are where most ESG stacks commit their quietest fraud. They treat reference data like a convenience file, a spreadsheet attachment, something you update when the new one comes out. That behavior rewrites history because an emission factor is not a number. It's a controlled assumption that converts activity into emissions. Change the assumption and you change the outcome. Which means if you can't prove which factor set applied to FY1, your FY1 numbers aren't evidence. They're a current interpretation of the past. Auditors don't assure interpretations, they assure records. So the rule is simple. Emission factors are controlled reference data with versioning, provenance, and effective dates. And once a period closes, the specific factor set used for that period becomes immutable evidence. This is the part everyone tries to shortcut with "we used DEFRA" or "we used EPA." That's not evidence, that's a brand label. What matters is the specific library version, the effective date range, the geography mapping, and the category mapping you applied. And here's the thing most people miss. Factor management isn't one table. It's a small system. You need at least 4 concepts in your model. 1, a factor library entity. This represents a published set you can refer to as a unit. It has a name, a publisher, a published date, and a status like draft, approved, and archived. 2, the factor records themselves, the actual conversion values, with units, gas type where applicable, and any classification fields you rely on in joins. 3. Applicability metadata, geography, sector, activity type mapping, and effective date range. If a factor is only valid for a country or only valid from a certain date, the model needs to carry that explicitly. 4. Provenance artifacts, where it came from and how it entered your system. That can be a link to an evidence document in your evidence vault, or, at minimum, a stored reference that can be produced during assurance. Now, the failure mode is predictable. Teams store factors in a table called emission factors with a column called factor value and no version key. Then calculations join to it using a natural key like activity type and country, and they default to latest. And it works until the factor table updates, then rerunning last year produces different results. And the team calls it an update. It is not an update, it is a restatement without governance. So the enforcement pattern is also predictable, factor to period binding. Every computed emission record must carry a factor version key, not a textual label, a key that ties back to a specific published library snapshot, and your calculation logic must require it. If the pipeline can run without specifying the factor version, you've built a machine that can rewrite its own past. This is where systems beat policy. Don't tell people don't use latest. Make latest unusable in period close processing. Use it only in exploratory analysis where you explicitly label the output as non-reportable. Then you build the publish workflow. Factors do not appear in production tables as ad hoc edits. They move through a life cycle. Draft factors exist in a working area. Someone reviews them, someone approves them, and then you publish a new library version. After publish, you lock it. That's where immutability enters again. The published factor library for a period becomes evidence, so it becomes worm protected. And yes, you can still correct factor data, you just can't pretend it was always that way. Corrections become a new version with a clear statement of impact, which future periods use it, and whether prior periods require an adjustment entry. Now, how does this land in a Microsoft stack without turning into another governance slide deck? In Fabric or Synapse, you implement factor libraries as tables with explicit version keys and effective dating. In your calculation views or notebooks, you join activity data to factors using activity classification, geography, and period date. But you don't let the join float. You require an input parameter for factor library version ID when producing reported outputs, or you bind the version through a period close configuration table that is itself locked after close. Either way, the output row carries the version ID. And you treat the factor library publish as a formal release. It's an artifact with approvals, it's registered in Purview, and it can be traced. That's how you answer the audit question in one sentence. FY1 used factor library version X published on Y, approved by Z, and locked on close. Without that, you'll end up in the classic assurance failure. Someone asks why FY1 changed, and you respond with, because the factors were updated. That response admits you don't have reproducibility. And if you don't have reproducibility, you don't have audit-grade ESG. Once factor versioning is real, KPI modeling stops being guesswork and starts being constrained engineering. That's next. KPI modeling, scope 1-3 energy water, workforce metrics, supplier coverage. Once factors are versioned, KPI modeling stops being a creative writing exercise and becomes what it always should have been: constraints encoded as data. Most ESG teams model KPIs like labels: Scope 1, Scope 2, Scope 3, water, diversity, supplier coverage. Then they build a dashboard and assume the definitions will stay stable because everyone agreed. They won't. So KPI modeling has one job: make the definition enforceable and make drift visible when someone tries to change it. Start with Scope 1, 2, and 3. These aren't tags you slap on at the end. There are structural constraints that determine what data qualifies, which factors are valid, and what boundaries apply. Scope 1 is direct emissions from owned or controlled sources. In system terms, Scope 1 activity records must bind to assets you control: boilers, generators, company vehicles, refrigerants. That means your data model needs an asset dimension, or at least an owned control attribute you can prove, not infer later. If you can't tie the activity record to the controlled asset set that existed during the period, you're back to narrative. Scope 2 is purchased electricity, heat, steam, cooling. In modeling terms, Scope 2 requires a clean separation between consumption and factor application because electricity data can arrive as meter readings, invoices, or allocations. Your model must preserve the original consumption units and the conversion path, and the output must carry which factor version applied, plus the geography and supplier mapping that justified it. Otherwise, you'll end up with global average factors quietly covering gaps and then spend months pretending it was intentional. Scope 3 is where the system either becomes honest or collapses. Scope 3 is a value chain problem, which means the model needs to handle mixed evidence quality, supplier-provided data, spend-based estimates, activity-based proxies, and hybrid methods. The common failure is forcing all of that into one column called emissions and calling it complete. So the rule is, every Scope 3 KPI must carry two flags: measured versus estimated, and coverage scope. Measured means supplier-provided or directly sourced activity with traceable factors. Estimated means proxy logic, with estimation factors treated as controlled inputs just like emission factors. Coverage scope means what part of the category this KPI represents. Percent of spend covered, percent of suppliers covered, percent of sites covered. Without those, your Scope 3 number is just a confidence trick. Now energy and water, because these KPIs attract the most casual denominator abuse. Consumption is easy, intensity is where you get audited. Energy intensity metrics require a denominator: revenue, production volume, floor area, headcount, output units. Denominators drift because someone changes the definition of revenue, or switches the production metric mid-year, or updates organizational structure mappings. So your KPI model needs to treat denominators as governed data, not as a measure in a dashboard. That means store denominators as tables with source, period, org unit, and definition version. Then compute intensity in the governed calculation zone and publish it like any other KPI. If someone wants a new denominator, fine. They get a new KPI variant with a new definition, not a silent rewrite of the old one. Water works the same way, but with more traps: local units, local reporting boundaries, and data that often arrives late. So the model needs quality flags: estimated, missing context, suspect spikes, late arriving. Don't hide those. Put them in the data set so the dashboard can surface confidence, not just totals. Workforce metrics are the quiet governance test. Headcount, turnover, training hours, safety incident rates, these are definition landmines. The calculation often depends on what counts as an employee, what counts as a contractor, which geographies are in scope, and how organizational units map to legal entities. If the HR team changes the underlying definition, your KPI changes without a code change. So KPI modeling for workforce metrics must include definition binding. A versioned definition record that states the inclusion rules, the denominator, and the aggregation level. Then the outputs carry that definition version key. Again, not a label, a key. And supplier coverage needs to be modeled explicitly because it's the only way to prevent vanity percentages. Covered must have a definition: covered by survey response, covered by verified activity, covered by modeled estimates. Each is a different confidence level. So store coverage as its own KPI family with numerator and denominator definitions and treat it like a first-class metric. Otherwise, you'll end up with a green dashboard that can't explain its own scope. Once your KPI model encodes scope, definitions, estimation flags, and denominator governance, the architecture can produce numbers that survive interrogation. And now we can talk about the failure modes, because they're not random. They're designed in. Failure mode 1, manual CSV overrides. If there's a single failure mode that shows up in almost every ESG program, it's this: someone fixes the number with a file. It always sounds reasonable in the moment. The meter export was wrong. The facility sent a correction late. The supplier portal didn't respond. The CFO wants the dashboard to match what finance believes is true. So a spreadsheet appears, then a CSV, then a folder called uploads, then a file name that admits the whole control model is imaginary, final V7. Here's what goes wrong mechanically. A manual override has no inherent chain of custody. It doesn't preserve who changed the value, what the previous value was, what justification existed, which approval covered it, and whether the period was already closed. A CSV is a blob of claims. Unless the system forces metadata capture and approval, the file becomes a silent rewrite of evidence. And once that pathway exists, it gets used for everything. First, it's just this one facility. Then it's just this 1 month. Then it's just this supplier. Then it becomes the default operating model because it's faster than fixing, ingestion, modeling, or validation. Entropy loves convenience. Auditors hate it for one reason: it creates an uncontrolled modification pathway inside the reporting boundary. That phrase matters because it doesn't matter whether the sustainability team is honest. It matters whether the system allows undetectable change. When a CSV can be uploaded and overwrite prior data, you have created a pathway where numbers can change without a durable trail. That's the definition of weak control. The classic symptoms are always the same. No reviewer trace. One person edits, one person uploads, and the approval is a Teams message. No locked period. The organization says the month is closed, but the storage and tables are still writable, so the month is closed in conversation only. No checksum. No content fingerprint. You can't even prove the file you showed the auditor is the file that produced the KPI. No binding to calculation logic. The override becomes the truth by brute force. Not because it passed through governed computation with known factors and known code. Now, the countermeasure is not banned spreadsheets. That's how you force shadow processes. The countermeasure is controlled submissions. If the business needs a manual pathway, you give them one that behaves like a ledger. Authenticated submitter identity, required schema, validation gates, and an approval workflow that results in an immutable publish. The CSV becomes a source artifact, not a rewrite tool. So the pattern looks like this. A submission is ingested into a staging area and tagged with metadata: who submitted it, when, for which site, for which period, and under which submission type. Then the system runs validation, schema checks, unit checks, required dimensions, and basic sanity thresholds. If it fails, it gets rejected or quarantined, not fixed later, quarantined with a recorded reason. If it passes, it does not overwrite anything. It gets published as a new versioned object into the raw zone. Append first, always. Then the important part, adjustments, not edits. If the period is still open, you can allow the new submission to become the latest accepted load for that period, but you still keep the older load as evidence. If the period is closed, the submission cannot mutate the closed outputs. It can only create an adjustment entry that is explicitly labeled as post-close, includes a rationale, and requires approval from a different role than the submitter. Separation of duties stops being an ideal and becomes enforced behavior. And yes, you keep the supporting evidence. The CSV file itself goes into the evidence vault with its metadata and, ideally, a stored fingerprint so you can prove integrity. The approval record goes into the vault. The validation report goes into the vault. This is how you build an evidence pack without rebuilding your memory. Now, here's the uncomfortable truth. The business will still demand just change the number. They always do. Your job is to make the only available change pathway one that leaves scars, a new version, a recorded justification, and a visible approval trail. When people complain that it's slower, that's the control working. And once you solve final V7 CSV, you'll notice the next failure mode is subtler. The dashboard itself starts rewriting history. Failure mode 2, calculation drift in Power BI. Calculation drift is the audit failure that feels like progress. Someone opens the Power BI model, sees a measure that looks inefficient, rewrites it, the visuals load faster, and everyone calls it an improvement. But the system didn't just get faster, it got less accountable. Because Power BI is designed for interactive analysis, not period-bound computation, its superpower is flexibility. And flexibility is the enemy of reproducibility when you're inside a reporting boundary. Here's what goes wrong. The ESG team builds core logic in DAX. Emission conversions, allocations, scope categorization, intensity denominators. It starts small. Then new requirements arrive. New sites, a new supplier category, a new framework question, a minor change to how renewable energy is treated. So they update the model, and historic values silently recompute. That's the difference between a calculation engine and a dashboard. A calculation engine produces outputs that become records. A dashboard recomputes every time it refreshes. When you change the logic, you don't just change future numbers, you change last year's numbers. This clicked for a lot of architects the first time someone asked for a prior year reconciliation, and the answer was the model changed. Not because anyone acted maliciously, because the platform makes logic edits trivial and makes version binding optional. Optional controls aren't controls. Now, the deeper problem is that Power BI doesn't naturally behave like a governed release artifact. Yes, you can manage workspaces. Yes, you can use deployment pipelines. Yes, you can restrict who can publish. But the model itself remains a moving object unless you design a release process that treats it like code that impacts financial statements. Most organizations don't. They treat it like a report. So you end up with the classic drift pattern. A developer optimizes a measure for performance. The measure changes, the outputs change. Nobody notices until a regulator, an auditor, or finance compares this year's report to a saved PDF from last year. And now you're in restatement territory, except you don't have restatement mechanics. You have a dashboard that rewrote history without leaving an obvious scar. That's why auditors increasingly flag logic-heavy DAX models. Not because DAX is wrong, because DAX is too easy to change without the control ceremony that should accompany changes to reported numbers. The architecture rule that stops this is brutal. Power BI is a thin semantic layer over reported tables only. That means the calculation zone produces the KPI tables. Those KPI tables are period-closed outputs. Power BI reads them. Power BI can aggregate and format them. It can create visuals. It can create drill paths. It can even create convenience measures that don't affect the underlying accounting of emissions. But it cannot be the place where emissions accounting lives. If you remember nothing else, DAX measures should be formatting, not accounting. Now, the system-level countermeasure is equally blunt. KPI outputs are tables, not measures. Instead of total scope 2 emissions being a measure that depends on 5 other measures, it becomes a column in a reported KPI table produced by Fabric or Synapse with keys for period, org unit, scope category, method, and factor version. Power BI then displays it. When someone asks, why did it change, you have an answer rooted in artifacts. Input load IDs, factor versions, and calculation release version. Not because someone updated the report. A practical control pattern looks like this. You publish a KPI dataset that is certified and only refreshes from the reported zone. You separate 2 dashboard classes, assurance dashboards that only read period-closed outputs and management dashboards that can read operational or provisional data. That distinction matters because management wants speed and iteration. Assurance wants stability and traceability. Mixing them guarantees you'll optimize for convenience and later pretend it was governance. And you still keep snapshots. At close, you export and store the period close report outputs as artifacts in your evidence vault. PDF for human-readable records and CSV or dataset extracts for machine traceability. Those snapshots don't replace the reported tables, they complement them. They prove what was presented at the time. Now here's the cynical truth. People will try to sneak logic back into Power BI because it's faster. They'll say it's just a small adjustment. They'll say we can do it as a measure. They'll say it's only for this visual. And then 6 months later, you discover the visual became the source of truth because it was the thing executives looked at. That's how drift wins. So enforce the boundary. Calculations in the governed zone. Outputs in reported tables. Power BI as presentation. And once you move logic out of the dashboard, you'll hit the next failure mode. Even with SQL-based logic, you still can't reproduce history if your emission factors float. Failure mode 3, missing factor versioning. Missing factor versioning is the failure mode that makes every other control look decorative. You can have immutable storage. You can have lineage. You can even have a governed calculation zone. But if your emission factors behave like current truth, you've built a system that recalculates the past with today's assumptions. That's not reporting, that's revisionism with a SQL engine. Here's how it happens in real architectures. A team centralizes emission factors in a table. They add a column for source and maybe year. They join activity data to factors by geography and activity type. Then, because nobody wants to pass parameters around, they add a view called something like VW emission factor latest. And every calculation joins to latest. It works until the factor set updates. Then you rerun FY1 in FY+2 and the numbers change. Not because the activity changed, not because the logic changed, because the factor table did what tables do. It reflected the current state. And your system quietly rewrote history. This is why we use DEFRA, isn't evidence. It's a marketing label for a library. Which version, which publish date, which effective dates, which geography mapping, which category mapping. If your answer is the one in the table, you are admitting you can't reproduce a prior close. And reproducibility is one of the audit-grade requirements you claimed you met. Now, what does assurance actually do with this? They ask the simplest question on earth. Prove the number. Not tell a story, prove it. They want to see the chain, activity record, factor record, and the logic that multiplied them. If the factor record is not pinned to the period, you can't prove what it was at the time. You can only show what it is now. That becomes ambiguity, and ambiguity becomes qualifications, restatements, or a scope limitation in an assurance report, depending on how bad it is. The most common real-world trigger is annual factor updates. A new factor library comes in, someone imports it. They overwrite last year's rows because it's an update. Then they rerun calculations to validate the new year. and suddenly last year changes. The dashboard still looks reasonable, so nobody notices until finance compares numbers to last year's submission or an auditor requests a reperformance for the prior period. And then the organization learns a painful lesson. Factor drift is indistinguishable from manipulation unless you can prove version binding. So the architecture countermeasure has to be enforcement, not guidance. First, you build factor libraries as version sets. A library has a unique version key. The factor records carry that key. And you never update an existing version. You publish a new version, always. Second, you bind factors to periods explicitly. That can be done through a period close configuration table that records, per reporting period, the factor library version IDs used for each domain: electricity, fuel, travel, freight, whatever you model. That configuration becomes part of the close package and gets locked after close because it's the switchboard that defines reproducibility. Third, you make the pipeline fail without a factor version key. This is the part teams avoid because it feels strict. Good, it should. In your SQL views, stored procedures, or notebooks, the join to factors must include the version key. If the caller doesn't supply it, the job fails. If the configuration table doesn't have a version for that period, the job fails. No silent fallbacks. No latest. No convenience. Because latest is an entropy generator disguised as a default. Once you enforce that, you can do an audit-ready rerun. You can take FY1 activity data. You can select the load IDs that were in scope at close. You can select the factor library versions recorded for that close. You can run the calculation artifacts tied to the released logic version. And you get the same result. That's what reproducibility means. Not close enough. The same. Now the subtle trap: effective dates and geography mapping. Even with version keys, teams still mess up by storing factors without applicability constraints, then joining based on best match. That produces probabilistic factor selection. So the factor model needs effective dates, geography codes, and classification keys that make selection deterministic. If multiple factors match, the pipeline should fail and force resolution, not pick one and pretend it was intentional. And the final piece is evidence. When you publish a factor library version, store provenance, where it came from and when it was approved. In Microsoft Sustainability Manager, factors can live in factor libraries. In Fabric or Synapse, you'll model them as tables. Either way, the published version used for a closed period becomes part of the evidence chain, so it gets locked and registered in Purview for Lineage. Because the moment you can't prove which factors were used, you're no longer defending a number. You're defending a belief about a number. And auditors don't assure beliefs. Purview, Lineage as your only defense against prove-it moments. At some point, someone will ask the question that ends the fun part of ESG. Prove it. Not explain it, not summarize it. Prove that this KPI came from these sources, went through these transformations, and landed in this report without being casually rewritten by whoever had access on a Tuesday. This is where most ESG stacks collapse because they rely on human memory and slide decks. That's not governance, that's folklore. Microsoft Purview is the mechanism that turns your folklore into queryable metadata. And that distinction matters because Lineage isn't a diagram you draw once. It's an operational record of how data moved, changed shape, and became something the business now claims is true. Lineage, in plain system terms, is origin to transformation to consumption. Origin is where the data came from. ERP extracts, meter feeds, supplier submissions, HR aggregates. Transformation is what you did to it. Validation, standardization, mapping, factor application, KPI computation. Consumption is where it shows up. Reported tables, semantic models, Power BI reports, exports. If any link in that chain is someone knows, you don't have lineage. You have a future incident. Here's what you actually register in Purview if you want it to be useful under audit pressure. You register the storage assets, lakehouses, ADLS paths, containers that correspond to raw, curated, reported, and the evidence vault. You register the processing assets, pipelines, notebooks, SQL endpoints, whatever actually performs transformations and publishes outputs. And you register the analytics assets, the datasets and reports people use, including the certified datasets that represent the assurance layer. And you assign ownership, real ownership, not the team, a named role with accountability. The thing most people miss is that auditors don't only ask, where did the number come from? They ask, who is responsible for this asset? Purview is where you make that answer deterministic instead of social. Now, what does this look like in practice in the moment you're under scrutiny? A stakeholder points at scope 2 for a region and says, this seems high. If you have lineage, you can trace from the Power BI visual back to the reported KPI table, back to the calculation view or notebook, back to the curated consumption table, back to the raw invoice extract or meter feed, and you can identify the load IDs and factor library version key used. You can do it in minutes. Without lineage, you do PowerPoint archaeology. You open old emails, you ask someone who left the company, you rebuild the path from memory and hope it matches reality. It won't. Lineage isn't only for auditors, it's also the fastest way to find where data quality issues actually entered the system. When a KPI looks wrong, teams usually blame the calculation. Half the time the calculation is fine and the input mapping is wrong, or the organizational hierarchy changed, or a unit got misread. Lineage gives you a breadcrumb trail, so root cause analysis becomes mechanical. Find the upstream change point, not the downstream symptom. And here's the other use case nobody budgets for. Impact analysis. Every time you change a pipeline, a mapping, or a factor library, you are changing a graph of dependencies. Without Lineage, you don't know what you'll break until something breaks. With Lineage, you can see downstream consumers before you ship the change. That's how you stop small improvements from becoming multi-year restatements. Now there's a reality check. Purview capabilities evolve, integrations change, some sustainability-specific solutions in the Microsoft ecosystem show up in preview states and then move. That is not a reason to avoid governance. It's the reason to avoid hard-coding your governance into documentation. Your architecture has to tolerate product drift by treating Lineage as a first-class system behavior. Register assets consistently, enforce naming conventions, keep ownership current, and make Lineage review part of release management. And yes, there's setup. You will configure connectors, you will manage identities, you will decide which assets get scanned and how often. You will deal with the fact that not everything stitches perfectly on day one. But you're not doing this for aesthetics. You're doing it because prove-it moments don't arrive on your schedule. They arrive when the board is watching. So Purview becomes your only defensible posture, a way to demonstrate end-to-end that your ESG numbers are products of controlled systems, not a collection of best effort narratives. And once you accept that, the next dependency becomes obvious. Governance without identity is theater. Identity is what turns metadata into enforcement. Entra ID plus role separation. Stop letting everyone be everyone. Most organizations say they have governance. Then you look at their permissions and realize they have hope. They treat Microsoft Entra ID like a login system, not what it actually is, the control plane for who can touch evidence, who can change logic, and who can publish numbers that will later be defended in an assurance room. That distinction matters because ESG fails when identity becomes optional. Role separation is not bureaucracy. It is the only reason an auditor believes your system didn't quietly rewrite itself under deadline pressure. So the model is simple, and it's intentionally boring. Submitter, validator, calculator, approver, report publisher. A submitter can provide data. They can't edit raw archives. They can't change mappings. They can't adjust reported outputs. A validator can review ingestion results and data quality exceptions. They can quarantine or accept with exception. They can't publish factors. They can't deploy calculation code. A calculator can run the governed compute process. They can't alter raw evidence. They can't approve their own changes. They can't publish the final report. An approver can sign off on period close, factor library versions, and post-close adjustments. They don't need broad data engineering access. They need explicit rights to approve, and their approvals need to be recorded as evidence. A report publisher can publish certified datasets and reports that consume reported outputs. They cannot modify the calculation logic or the data inputs that produce those outputs. If you collapse those roles into the sustainability team, you've built a system where the same identity can create data, change data, compute results, and approve results. That is not control. That is conditional chaos. Now here's the part everyone tries to dodge. Access boundaries by zone. Raw, curated, and reported are not just storage partitions, they are permission boundaries. Raw should be readable by the people who need to trace provenance and resolve ingestion issues, but writable only by controlled ingestion identities, typically service principals executing pipelines. Humans don't get write access to raw evidence, they get a submission mechanism that produces new immutable artifacts. That's a different thing. Curated should be writable only by the transformation process, identities, and the engineers responsible for the model. Broader read access is fine, but write access is a scalpel, not a group membership. Reported should be locked down hardest. Write access only for the closed process and controlled adjustment workflows. Read access for reporting, finance, internal audit, and whoever consumes the KPIs. But nobody should be casually updating reported tables because it's just a fix. Fixes are adjustments. Adjustments have approvals. Approvals have identity separation. And yes, all of this is enforced with Entra groups, service principals, managed identities, and RBAC assignments at the storage and compute layers, not in Visiodont in the system. Now, evidence of control matters as much as control itself. You don't just need permissions. You need proof of permissions. So you treat Entra assignments, role memberships, and privilege changes as part of the assurance package. When the auditor asks, who could have changed this? You don't answer with a meeting. You answer with access history, role definitions, and audit logs. Which brings us to the most common ESG security anti-pattern, the hero admin. The hero admin shows up when the pipeline breaks, the close date is near, and somebody says, just give me contributor for a minute. Temporary elevation becomes permanent. Exceptions become normal. And then months later, you discover your separation of duties is a myth because everyone has been operating as everyone. The countermeasure isn't trust people more. It's making elevation visible and costly. If you must allow privileged access, you make it time-bound, explicitly approved, and logged. You treat it as an incident artifact, not a convenience, because every exception is an entropy generator that will be reused. And here's the awkward truth. The sustainability organization will fight you on this. They'll say it slows them down. They're correct. Controls always slow down change. That's the trade. If you want audit-grade reporting, you don't optimize for speed of edits. You optimize for survivability under scrutiny. So you design the workflow so the compliant path is the easy path, controlled submissions instead of shared folders, approved factor publishing instead of spreadsheet swaps, period close gates that lock storage, and reports that only read from reported outputs. Entra is what makes all of that enforceable. Without it, Purview shows you lineage of data that anyone could have altered. That's not governance, that's cataloging your own uncertainty. Next, we talk about where organizations reintroduce entropy for convenience, the reporting layer. Reporting layer, Power BI as presentation, not truth. Reporting is where most teams undo everything they just built because Power BI makes it easy to be helpful. Helpful is not a control objective. In an auditable ESG stack, Power BI is a presentation layer, a thin semantic layer over reported outputs. It does not own the math, it does not fix missing data, and it does not quietly restate history because someone wanted a cleaner chart. The system behavior you want is simple. Fabric or Synapse produces period-closed KPI tables in the reported zone. Power BI reads those tables through certified datasets. The report is a window, not a calculator. That distinction matters because the report is the thing executives screenshot, regulators request, and auditors reconcile against the evidence package. If the report can change without a corresponding change in the reported tables, you've created a second truth. And you will spend the next year arguing with yourself. So you build two classes of dashboards on purpose. The first class is regulatory and assurance reporting. It reads only from the reported zone. It refreshes on controlled schedules. It uses certified data sets. It has locked definitions and a release process that looks boring on purpose. The second class is management and operations reporting. It can read curated and even operational data. It can move quickly. It can support what's happening right now. Questions. But it is explicitly labeled as operational, not reportable. Different audience, different expectations, different tolerance for drift. If you collapse those into one dashboard, you'll optimize for executive convenience and accidentally publish it as evidence. Now, even in a thin semantic layer, you still need governance because semantics are where definitions drift. Use certified data sets, not personal workspaces and not an analyst's final PBICs. Certification is the signal that the dataset is backed by controlled sources, has an owner, and is part of the assurance boundary. Promoted is not enough. Promoted is a social tag. Certified is a control decision. Control the refresh path. If the dataset refreshes from curated tables, someone will eventually change a curated transformation and unintentionally shift a number that was treated as stable. Assurance datasets refresh from reported tables only. That's the rule. Then you design the visuals that actually survive audit scrutiny. Auditors don't care about your color palette. They care about your ability to explain. So the mandatory visuals are the ones that surface control-relevant context. Targets versus actuals, yes, but also confidence indicators. Measured versus estimated split. Coverage metrics alongside totals. And explicit period labels tied to close status. A Scope 3 total without a coverage indicator is not a KPI. It's a mood. You also enforce drill path discipline. The drill path needs to be deterministic, group to region, to site, to source record identifiers, not click until you find something that looks wrong. When a number gets challenged, the report must let you drill to the reported record grain, then provide the keys that let an engineer trace lineage back through Purview, period, org unit, load ID, and factor library version key. If the drill stops at an aggregated chart, your report is a poster, not an audit artifact. Now the part everyone ignores, export strategy. At period close, you snapshot the outputs, not because Power BI is unreliable, but because people are. Auditors often want exactly what was presented at close, and they want it reproducible even if someone changes a report later for internal reasons. So you export close packages, a PDF snapshot for human-readable continuity, plus a data extract that matches the reported KPI tables for machine comparison. Store both in the evidence vault with the close metadata, period, dataset version, report version, and approval reference. This is not redundant. It is defense against we changed the report layout becoming we can't reproduce what we filed. A practical warning. The easiest way to reintroduce calculation drift is to allow just one measure to creep in. Someone will say the reported tables don't include a ratio they want, or the business wants a different intensity denominator in a visual, or they want to adjust a mapping in the report because it's faster than waiting for the next pipeline run. If you allow that, Power BI becomes the calculation engine again, slowly, one convenience at a time. So the rule stays harsh. The only math allowed in Power BI is presentation math. Formatting, simple aggregations that don't change accounting semantics, and convenience measures that do not become the source of truth. Anything that changes the meaning of a KPI belongs in the governed calculation zone, gets versioned, and gets published into the reported tables. Because the only thing worse than having no ESG story is having two optional components: Sustainability Manager, ADF, Azure ML, where they fit. Optional doesn't mean irrelevant. It means the component is not part of the minimum control surface required to survive assurance. You add it when it reduces audit risk or operational friction, not when it makes the demo prettier. Start with Microsoft Sustainability Manager. Microsoft Sustainability Manager is useful when the organization needs structured workflows and a sustainability-focused data model without inventing everything from scratch. It positions itself around record, report, and reduce. That's not marketing fluff, it's a workflow boundary. It can unify siloed data, run emissions calculations, and support reporting modules. But the architectural question isn't, is it good? The question is, does it help you enforce intent? Where it helps is governed data collection and auditability inside its domain. The platform can track data changes. It can enable auditing for sustainability tables in Dataverse. It also has data trail report capabilities described as Purview, producing traceability across inputs, calculation models, logs, and outputs. That can be valuable when your current state is uncontrolled spreadsheets and tribal knowledge, because it gives you a default control story you can actually show. Where it doesn't help is when you treat it as the system of record for everything and stop caring about reproducibility at the platform boundary. If you already have mature emissions logic, strong factor governance, and a deterministic lakehouse model, Sustainability Manager becomes optional. You might still use it for workflow and data collection features, but you don't outsource your assurance posture to an app. And if you do adopt it, be honest about constraints. Auditing configuration is blunt through the standard interface. It's all or nothing for sustainability tables unless you use the Power Platform Web API for more granular control. That's manageable. It's also a reminder that audit-ready still requires engineering. Next, Azure Data Factory. If you're all in on Fabric native ingestion and your source landscape is simple, ADF is optional. Fabric can ingest, Fabric can orchestrate, and for many organizations that's enough. But ADF remains valuable when reality shows up. Complex ERP extraction, IoT fan-in, API rate limits, cross-system dependencies, and multi-step orchestration that spans networks and security boundaries. ADF is the thing you use when you need the pipeline to behave like an integration system, not like a notebook with optimism. Just remember the immutability constraint you already accepted. ADF will fail when you try to overwrite immutable paths. You'll see errors like path immutable due to policy because the storage layer is doing its job. And for certain transformation patterns, ADF data flows can't write directly to immutable containers because they rely on temporary files. The pattern stays the same. Write to a mutable staging destination, then copy finalized outputs into the immutable evidence zone. So ADF isn't more enterprise, it's more orchestration. That's different. Now, Azure Machine Learning. It's optional because it doesn't produce baseline numbers. If it does, you're building a probabilistic accounting system. You can't audit a model's intuition. Use Azure ML for three things only: forecasting, anomaly detection, and scenario modeling. Forecasting helps planning. Anomaly detection helps data quality. Scenario modeling helps reduction strategy. None of those are the reported KPI baseline. They are overlays, and they must be labeled as overlays in the data model and in the reports. Model outputs should carry model version, training data window, runtime stamp, and clear classification as estimated forecast. And otherwise, you'll inevitably promote a forecast to a fact because it looks clean on a slide. So the decision rule is harsh. Add optional tooling only when it reduces audit risk, not when it reduces effort. Sustainability Manager reduces chaos when you need structured collection and built-in sustainability workflows. ADF reduces fragility when integration complexity exceeds what Fabric orchestration can realistically manage. Azure ML adds intelligence, but only if you keep it out of the accounting path. Optional components don't replace the fundamentals. They either reinforce them or they accelerate your failure in a more expensive way. Next, a short comparison, because every stack can calculate emissions. Very few can prove them end-to-end. The short comparison: Microsoft versus Snowflake, Databricks, GCP. At this point, someone always asks the same question, usually with a budget spreadsheet open. Why Microsoft? Why not Snowflake? Why not Databricks? Why not just do this on GCP? And the answer is not that those stacks can't calculate emissions. They can. Any competent data platform can ingest activity data, join it to factor tables, and output a number labeled Scope 2. That part is not rare, it's table stakes. The problem is that assurance doesn't reward computation. Assurance rewards proof. So the comparison only matters on three axes: identity and access control, lineage and governance, and audit evidence as a first-class output. Everything else is noise. Start with identity and access. Microsoft's advantage is not that Entra exists. Every cloud has IAM. The advantage is that the identity plane is already the enterprise default for most organizations running Microsoft 365, Azure, and Power Platform, and it reaches into the services you're using for ESG, storage, compute, BI, and workflow. That matters because role separation isn't a concept. It's a continuous enforcement problem across the entire stack. In Microsoft land, you can actually make submitter, validator, calculator, approver, publisher map to real groups and real permissions that propagate into the services doing the work. In many non-Microsoft stacks, identity becomes an assembly task. Not impossible, just assembled. And assembled identity is where temporary access becomes permanent, where service accounts become shared, and where your separation of duties quietly turns into conditional chaos. The platform didn't fail you, your architecture did, but the platform determines how hard it is to fail. Now, lineage and governance. This is the axis where most ESG teams discover the difference between we have data and we can explain data. Microsoft Purview is not magic. It's just a governance plane that is designed to be a governance plane. You register assets, you scan, you capture lineage, you assign owners, you query metadata, you walk into an audit room with something more defensible than a diagram in Confluence. And because Purview integrates into common Microsoft data services, you can build lineage that spans ingestion artifacts, lakehouse or warehouse objects, and Power BI consumption in a way that is operationally achievable. In other ecosystems, governance is usually a product stack you bolt on. Databricks has Unity Catalog and Lineage capabilities in its ecosystem. Snowflake has governance features and partners. GCP has data catalog and governance tooling. All of that can work. But the single pane of glass story becomes single pane of glass after integration work, which means it competes with everything else for time, budget, and political attention. Over time, governance loses those fights, not because people are lazy, because they get measured on delivery, not survivability. So Microsoft's practical advantage is not perfection, it's friction. Less friction to do governance well means it's more likely to happen and more likely to stay current when the system evolves. That is what auditors actually experience. Now, the third axis, audit evidence. This is the point that makes most platform comparisons meaningless. Audit-grade ESG is evidence management, immutable raw inputs, versioned factors, versioned logic, period close configuration, controlled adjustments, snapshots, access logs, approval trails, reproducible reruns. That's the system. The report is just an output. Microsoft doesn't automatically give you this either, but the architecture aligns with it because the components map cleanly to the evidence lifecycle. Entra gives you the enforcement surface for role separation. ADLS Gen 2 with Immutability gives you the evidence vault behavior. Fabric or Synapse gives you the governed compute surface, where you can implement deterministic calculation artifacts. Purview gives you lineage as queryable metadata instead of oral tradition. Power BI gives you presentation without forcing you to mix computation and visualization. That collection forms an integrated control plane story, not a vendor story, a control story. In other stacks, you can absolutely build the same control story. But you build it. You assemble the identity controls across tools. You assemble lineage across transformation engines and BI. You assemble immutability patterns across storage and pipeline behavior. You assemble evidence packs as a discipline, not a platform feature. And every assembly point becomes a place where policy erodes, because policy always erodes when intent isn't enforced by design. That's the uncomfortable truth. Architecture is what remains after your governance committee stops meeting. Now, to be fair, there are reasons teams choose Snowflake, Databricks, or GCP for ESG. They might already run their entire analytics estate there. They might have stronger internal skills on that stack. They might have vendor constraints or data gravity that makes Microsoft the wrong place to compute. None of that is invalid, but if they choose those platforms, they still have to answer the same assurance questions, and they still have to build the same non-negotiables: immutability, reproducibility, lineage, separation of duties. The stack changes, the physics don't. So the short verdict is this: all stacks can calculate emissions. Very few stacks can prove them end-to-end without deliberate architecture that prioritizes evidence over convenience. Microsoft's advantage is that it gives you a coherent set of primitives that align with audit survivability, especially in organizations already living inside Entra, Microsoft 365, and Azure. And this episode was never about vendor fandom. It was about building something that survives contact with assurance, which is why the next section matters more than the comparison. The minimal viable auditable ESG architecture is the part you can actually replicate. Minimal viable auditable ESG architecture, the replicable blueprint. Here's the part people pretend they want until it forces decisions. A minimal viable auditable ESG architecture isn't minimal because it's cheap or quick. It's minimal because it contains the smallest set of components and artifacts that can survive assurance without turning your team into full-time historians. So define the MVAS clearly: boundaries, components, and produced evidence. The boundaries are 4 zones: raw, curated, reported, and an evidence vault. Not because medallion architecture is fashionable, but because it's the cleanest way to separate what happened from what you did to it from what you claim. The components are 5: Entra ID, ADLS Gen 2 with Immutability, Fabric or Synapse for governed compute, Purview for Lineage, and Power BI as a thin presentation layer. Everything else is optional, and optional means it's allowed to be absent without collapsing audit survivability. The artifacts are what make it auditable: load IDs and ingestion logs, immutable raw objects, governed calculation artifacts with version control, factor library versions with approval records, period close configuration, reported KPI tables, and a close package snapshot. If you don't produce those artifacts, you didn't build an auditable system. You built a dashboard. Now walk through one KPI end to end, because architecture without a trace is just a diagram. Pick Scope 2 emissions. It's common enough, and it's where drift and factor ambiguity show up fast. The source is activity delta, electricity consumption by site and period from invoices or meters. Ingestion lands it in the raw zone as append-only objects. Each load gets a load ID, timestamp, source identifier, and submitter identity. If the ingestion came from a human submission, it still lands as a new versioned object. No overwrite, ever. Validation runs before anything becomes curated. Schema checks, unit checks require dimensions like site, period, and measurement type. The validation output is not a log line in a pipeline run. It's an artifact you can retrieve later. Pass, fail, warnings, and what was corrected or normalized. Then curated, you standardize the shape. Sites map to org units. Units normalize. Missing dimensions get flagged, not silently filled. This is also where you enforce controlled vocab: electricity type, supplier identifiers, region codes. The curated tables carry quality flags forward because clean data that hides uncertainty is a liability. Then the calculation zone: Fabric, Lakehouse, or Synapse. This is where Scope 2 emissions gets computed using versioned logic, not DAX. Not the report, a governed artifact. The computation binds to 2 things explicitly: the activity load IDs and the factor library version key. If the job doesn't have a factor version key, it fails. If multiple factors match due to sloppy mappings, it fails. Deterministic selection or no selection. Now, period close. Period close is not a calendar event. It's a state change that freezes your ability to rewrite the past. You freeze the inputs by selecting the accepted load IDs for the period. You freeze the factors by binding the approved factor library version IDs to that period. You freeze the logic by referencing the released calculation artifact version. Then you publish the reported outputs, the KPI tables for that period with keys for period, org unit, method, measured versus estimated flags, and the factor version key used. Then you lock as ADLS immutability applies to the raw evidence and to the published close artifacts, factor library snapshot, close configuration, and reported outputs as needed for your evidence strategy. You don't have to make every table immutable forever. You do have to make the close package immutable. That's the point. Then Power BI. Power BI reads reported tables only. The dataset is certified. The refresh is controlled. The visuals include the confidence context, measured versus estimated, coverage indicators, and the drill path down to record identifiers. When someone challenges the KPI, you don't debate. You drill, and Purview stitches the whole path. Power BI report to dataset, dataset to reported tables to calculation artifacts to curated inputs to raw loads to sources and submission identities. That lineage is not for beauty, it's for the day someone asks, prove it, while your calendar is already on fire. Finally, sequencing, because this is where most teams implode by trying to boil the ocean. Week 1, pick 1 KPI and 1 data source. Build ingestion into raw with load IDs and validation artifacts. Week 2, build the curated model for that KPI, including quality flags and controlled dimensions. Week 3, implement the governed calculation zone with factor version binding and a reported output table. Week 4, register assets in Purview and build a thin Power BI report that drills to record IDs and shows factor version keys. That's done. Not perfect, done in the only sense that matters. The auditor's questions are answerable from systems, not from meetings. Auditable ESG in Microsoft isn't about dashboards, it's about immutable data, versioned calculations, and lineage you can explain to an auditor without PowerPoint. If you want the next layer, the ESG data model itself, raw versus curated versus reported, and how to enforce period close, watch the next episode and subscribe.